Okay, we're going to go ahead and get started. Thank you very much, everyone, for joining us today. My name is Bob Walker, and I am the leader of the customer solutions team here at Octopus Deploy. And joining me today is Shawn Sesna, one of our senior solutions architects on that same team. And today we're going to be talking to you about managing Octopus Deploy with our Terraform provider. Shawn, how are you doing today?
I'm actually doing really, really well this morning. How about yourself, Bob?
I'm doing really well as well. I'm really excited to talk about this because it solved a couple of our problems that we're running into with our samples instance, and I can't wait to share it with our users.
Yeah, it certainly did. I was actually really excited to work on this project with you.
Yeah, it like I said, it definitely solved a number of some of the different issues, and we'll get into that in just a second. But before we do that, just a little bit of housekeeping. A link of the recording will be emailed to you. And if you have any questions, if you are on one of our non-Zoom platforms, please drop that question in our community Slack, and we'll get back to you on that one. But if you are on Zoom, please use the webinar Q&A feature. It's a lot easier for us to keep track of what questions are being asked and whether or not we've answered them directly, or if we're going to answer them as part of the recording. So I'd like to start off with an agenda. That way you kind of know where you're going to be spending the next hour or so. So first off, we're going to start off with an introduction to Terraform. Nothing super in depth because Terraform is a massive, massive tool. Then we will jump over into a demo. And then finally, we're going to wrap it up with some Q&A. But before I do get started, I do want to point out that the Octopus Terraform provider, what we're going to be showing you today, is not the same as the config as code feature. And there are some differences between the two. So with Terraform, you can manage almost any resource in Octopus Deploy, whereas config as code is at the project level only. Specifically right now with the first release, it's going to be at the deployment process only. With Terraform, everything you do is going to be managed by Terraform, including managing the Terraform files, state, everything like that. Meanwhile, with config as code, you can either make changes using the Octopus Deploy UI or directly in the OCL files. And finally, with Terraform, you're responsible for managing all of the lifecycle. There's no integration directly with an Octopus Deploy in terms of like direct management, specifically with your Git repo. Whereas with config as code, the Octopus Deploy UI has integration with your Git repo. So I just wanted to point out those kind of very key differences, and we will be focused in on the Terraform provider. So if you're not familiar with Terraform, just a brief introduction. It is infrastructure as code, where you're defining your resources in human readable format. And we'll get into what resources are in just a little bit when we do the demonstration. But what you're going to be doing is you're going to be defining those resources either using JSON or HCL, which is HashiCorp configuration language syntax. Now, Shawn, I have my preference. I'm kind of curious, what's your preference in terms of files? Do you like JSON or do you like HCL?
As part of this project, Bob, I had to work a lot in ARM templates with some of the stuff that we did. So I actually much prefer HCL versus JSON because those ARM templates was just gnarly at times.
Yeah, I found that HCL is also a lot less verbose. So I know what you mean. I've worked with ARM templates myself. Nothing but sympathy for you on that. Uh, but in terms of like what does Terraform support? So it has kind of different levels. So there's like the first class citizens are provided by Terraform itself. So those are the default providers such as Azure, AWS, and GCP. In addition, a number of different software vendors also have a Terraform provider, such as Octopus Deploy. This is, say, our official Terraform provider with documentation, and it's fully managed by Octopus Deploy. But then there are also providers out there that are also managed by the community. And there's not different layers in terms of like one's better than the other. It's more like where is the source of the truth coming from. So we are going to be talking about the Octopus Terraform provider. And it was added to Terraform way back in January of 2021. Shawn, I don't know about you, but sadly, this was my first time using it. So it had been almost a full year it had been being out before I started diving into it.
Same here. I knew it was there. I knew customers were using it, but I just hadn't had an opportunity to get in there and delve into it myself until this project.
Yeah. And once we dove in, we got to see all kinds of new and interesting features, which I was really happy we got to finally get to do it. But yeah, it has been around for quite some time. It is still actively being developed. It hasn't reached version 1.0 yet. There's still some items that are not fully managed by Terraform. One particular one is step templates, as at the time of this recording anyway. There are just a number of different little niceties and things that we want to make sure we have in there before we add, say, step templates and everything around that. Now, I kind of knew this behind the scenes that the Octopus Terraform provider is a wrapper around the Octopus Deploy API. And you'll see that when we start looking at some of the state files, how we keep track of what the unique identifier is. And additionally, we use it internally to help manage both Octopus Cloud. So when I say we use it to manage Octopus Cloud, believe it or not, we use Octopus Deploy to deploy Octopus Cloud instances. And those are all managed, like those processes are all managed by our Terraform provider. So we actually have all of that managed by Terraform. We also use it to manage our samples instance. And we'll get into that. That's going to be the demonstration for today, is to talk about how we are using it to manage our samples instance. Different problems, different use cases, but generally the same core rules are going to be the same. I do want to talk a little bit about what we're going to be covering for the demonstration, just so you kind of know where we're going, because we're going to spend quite a bit of time talking a little bit about our samples instance at the end of 2021 and some of the challenges we were running into. We're also going to talk about some of the goals of what we wanted to change, as well as do a deeper dive into Terraform. Specifically, we're going to talk about resource ownership. We're going to show you its Terraform state files and why you need to know about those, how you manage pre-existing resources and variables. And then most importantly, we're going to talk about when not to use Terraform, because there are certain use cases where it doesn't make a whole lot of sense, depending on how you want to use it, I guess. But there are also great use cases of when to use Terraform. But we're going to highlight, what's the best time to use one over the other. So let's jump right into the demonstration. So this is our samples instance. And if you're not familiar with our samples instance, it was created all the way back in 2019. Were you surprised by that, Shawn? I was a little surprised. I thought it was 2020.
I could have swore it was 2020 because 2019 is when I joined the team, and I don't remember using it way back then.
Yeah, I had to look at our internal billing system where we quote unquote get billed for free. And I saw it started in 2019. I'm like, oh, wow. I do remember when we first created it, because I was in a hotel room actually creating it to help out one of our customers. But it was designed to help show how to use Octopus Deploy with a whole variety of different samples. So if you were to come here, and this is publicly available to everybody, they can log in as a guest and they get access to all of these different examples. So we have topics covering different patterns, as well as different target types. So you can be doing Kubernetes, or maybe you want to deploy to MySQL. And we have samples for every single one of those that you're seeing on this list. Now, when we started building out the samples instance, obviously there's nothing there. And it's kind of the Wild West, wasn't it, Shawn, when we first started off?
That's an understatement, Bob. The team was really small back then, so it was just a
Yeah.
few of us. But there was a bunch of us going in there creating all sorts of samples, and there wasn't a whole lot of consistency to it, unfortunately.
And that's one of the things that you kind of stepped in and started doing, is starting to apply consistency across all of our spaces.
Yeah, it was mostly because all of us had really, really great ideas, but we all
Mm-hmm.
did things just slightly differently. So when a customer came to the site, it was a little disjointed, and things weren't always in the same spot. So I came in, I wrote up some guidelines on making things to be more consistent. So as you go from space to space, looking at examples, you had a pretty good idea of where to find what you're looking for.
Yeah, but it was still very much, you had to manually kind of enforce all of those. You go through each space and you're cleaning them up as you went, right?
Absolutely, yeah, and
Yeah.
it did take quite a bit of time to get things looking the way I really wanted them to.
Yeah. And like you said, we all had really good ideas, but we all kind of fell into our own, I would say, habits, bad or good or otherwise. I think a really good one that I want to talk about, which is another problem that we're trying to solve, which was when we'd stand up an example and say Azure. I don't know about you, but I would typically just pick the closest data center, find a sample that I'd previously worked on, and just start copying in all of these settings. Like I almost blinded copy paste.
Yeah, that's pretty much the same. And the same went with some of our UK folks.
Oh
They
yeah,
also did the same. They selected London because it was closest to them, which made sense.
yeah, absolutely. And then we were asked by our security team as we're kind of going through constantly evaluating our security. It's like, hey, it would be great if we can move all your samples over from this subscription to another subscription. So you had to go through I went to the wrong place, but each of our Azure accounts, for example, and change on every single space this account, which I imagine wasn't a whole lot of fun.
No, it wasn't terribly a lot of fun. Thankfully, Mr. Harrison, another member of our team, wrote a script to add the subscription to all the spaces, but we still had to go in there and switch them out.
Yeah. Yeah. Plus, there's a lot of like cleanup that you had to do because some things weren't quite the same when we switched subscriptions. I remember like some of the resources available to us wasn't quite the same. Like I think like the number of vCPUs per region or something like that.
Yeah, yeah, there was a quite a number of different what do they call them, quotas that I had to go
Yeah,
through
that's what it
and
was.
adjust to make sure that all of our resources could get stood up.
Yeah, absolutely. And so what kind of I think what we kind of found out was as we were building out these samples, and we still want to build out more samples in this instance, is every time we want to create a new sample, we have to create a new space, which kind of turned into a pretty big endeavor because not only you have to create the space, but we also have a number of other things you have to do aside from creating the environments. You have to create the library of variable sets on terms of Azure or maybe notifications. We also have rules in place in terms of teams and permissions. So the three big teams is everyone, which has permissions to read only permissions to every single one of our spaces and examples. We have Octopus employees. So if you're an employee, for example, you get permissions to create some releases and deploy those releases and maybe run some runbooks, but you can't change anything. We didn't really want to give kind of blanket change permissions to everyone and accidentally make a change that they weren't supposed to. But then anyone that's on the customer solutions team, they have Octopus Manager's permission, which basically means they have Space Manager across every one of our spaces. So again, these are the types of standards and some of the goals that we're looking to do is make it easy to stand up a new space, but also have a set of standards across all of our spaces as well. I think the other one I kind of wanted to talk about because we're going to be talking about this quite a bit is within our life cycles. So we wanted to make sure that we were good stewards because this is a cloud instance and we are paying for it one way or another. And we wanted to make sure we weren't wasting space by having way too many releases. I think at one point like we were keeping an unlimited number of releases or something really ridiculous, and so we wanted to cut it down to say 5 days worth of releases. Um, so those are a number of the different things that we kind of had in place. So let's take a look at the Terraform that we came up with and kind of show you kind of what we were doing behind the scenes. So if you're not familiar with Terraform, one of the nice things about it is you can divide up a whole bunch of different Terraform files. Sorry, have a whole bunch of different Terraform files, and Terraform will see all those files and basically combine them automatically for you. So we've divided it up based on like the types of variable set, external feeds, accounts, uh, worker pools, etc. We start off with the main one. So what you're doing here is you are declaring what provider you're going to use. So in our case, we're using the Octopus Deploy Terraform provider. And then you also have to declare the state file. Now, this was something I I think kind of took me by surprise about Terraform was the whole state file and the whole backend that you have to kind of worry about. Because by default, if you don't declare anything right here, Terraform will use this. Sorry, it will store the state file in a directory relative to where you're running it. And that kind of caused a little bit of problems because we're running everything on workers. So the state file might not be there on that worker later the next time we run something. And we want to keep on maintaining that state. And so the way that Octopus Deploy works is you declare all your Terraform files. And for example, we're going into the external feeds. And so what we've done here is we are using Terraform to declare that we want to have 3 different types of feeds in any space that we're going to be using. And then it uses that information. So this is the desired state, and then it compares it against a state file here. So this is a sample state file that we downloaded. Uh, we've cleaned it all up so there's no sensitive values or anything like here, so we feel comfortable sharing it with everyone. And then what Terraform does is it compares those Terraform files with your state file, and then in our case, Octopus Deploy, and goes, okay, what's different? So if it sees a new resource in your Terraform file that's not in state, it will try to create it on Octopus Deploy. If it sees that you have changed something in your state file, your Terraform file, and then it will compare Octopus Deploy and go, oh, I need to create something new, or I need to modify a parameter or a property. In addition, if it thinks that something should be in a state file that's not in that state file, it will go ahead and try to like recreate it or try to update it or anything along those lines. And so this all kind of, I'd say this kind of all caught me off guard by this whole desired state. Now, Shawn, I know you're a big fan of desired state, aren't you?
Yes, I am. At my previous job, one of the things that we encountered in our DevOps journey was the environments were not always consistent. So I started
Mm,
researching and I started using PowerShell desired state configuration so that the confidence that our developers had that each server, as they went from environment to environment, was configured exactly the same. Because you could do the best you can with checklists, but
hmm
or even using that golden image example, but still, that image gets outdated as soon as you install it. So
Yeah. Oh, yeah. Yeah. And that's, again, that's one of the things I like about Terraform is that you are declaring this like, hey, we want to have this feed type, and I can show you all the different types that we have, but it kind of just reinforces the same thing. I want to have a GitHub feed, I want to have a Docker feed, and so on and so forth. And so, really, it's a combination of your Terraform files you're defining here, as well as your state file. Those are the two most important pieces, kind of in your whole Terraform experience. But there are some uniqueness, I would say, unique challenges that we run into because each space that have we have. So I showed you these life cycles that we have. But if I were to say come into, I think it's target serverless is a really good example. I'll get there eventually. There we go. You'll notice we don't have the same number of environments. So the last space we were on, we had dev, test, staging, and production. On this space, we just have test and production. In addition, if we go into the life cycles, we have completely different life cycles, obviously. Some are using the default life cycle where it's just doing things by convention. Meanwhile, other ones we have kind of auto deploy production. So every space has its own life cycle, and every space has its own environments as well as run books. So this again kind of caught me off guard about Terraform because with Terraform, it's an all or nothing deal. I can't say I only want to keep 3 days worth of releases. I can't just say I just want you to manage this one particular item on my resource. It has to be everything. It's the phases, it's the name, it's the description, it's the retention policy, it's everything about that particular resource. And so we so what we did to kind of get around this was actually we already had some prior art because Shawn, if I recall, we had an API script floating around out there to enforce these retention policies, right?
yeah, we started using runbooks and had forgotten the fact that it keeps 100 runs per
Ah,
runbook, and we had a lot of runbooks, so we needed to clean up our own mess and change that policy to a much lesser number.
yeah. So it was nice that we already had those API scripts. So what we ended up doing was we would say, okay, by default, we want to look at Terraform. We want to have Terraform manage this. But in cases where we want to have the ability to allow each space to define their own environments, to define their own life cycles, specifically the retention policies, or define their own runbooks. What we started doing was in those particular cases, we actually were using API scripts. So I'm going to jump back over here. And so we have a few API scripts kind of used to manage some of those bits and pieces. So we have, say, lifecycle policies is a really good example of an API script that's just used to manage the maximum number of days allowed for a release retention policy. One other thing that kind of took me by surprise, I don't want to say it took me by surprise, but I did want to point out was within Terraform, you have to define this explicit resource like that you want to manage. So we have to define this, hey, we're going to have a feed this is going to be the type, be the name. You have to define that explicitly. While Terraform does provide some ability to have some dynamic stuff, I found that to be a little bit more confusing because you're not 100% sure what's going to get created. I prefer to be more explicit than implicit. Again, I thought that was rather interesting to me. I don't know about you, Shawn. I don't know why I was expecting it to be more dynamic than what it was.
Yeah, it's similar to PowerShell DSC in that there are certain
Hmm.
things that you absolutely have to define in order for things to remain consistent. Because having things be dynamic, sometimes it doesn't quite work when you need to manage things explicitly saying it has to be this way. So if it's dynamic,
Hmm.
it just may not come out always the same, and it will constantly tell you it's drifted.
Yeah, that's a really good point. Yeah. And then the other thing is that when you don't have items in your state file, I think we already talked about this, that it will try to create them, which is not necessarily a good thing because in our case, we actually had a number of, if we went to like our external feeds, some of our spaces already had a Docker feed, and some of our spaces already had, say, GitHub feed or both. And I didn't want to have to recreate those and have to go through our deployment processes and change everything over to use these new feeds because that was kind of a waste of time. And so what I wanted to do is I wanted to run through and import those existing items into state. And it is possible, and we'll show you how that's done. But I just wanted to point that out as well. It's like that's another one of the challenges is that there are some items that we wanted to create brand new and migrate over, and then other items we wanted to reuse and just put them under management of Terraform. But again, I just wanted to point that out. But I think the kind of the last big thing that I've kind of been dancing around a little bit is once you put an item into Terraform. So in this particular case, so I have these feeds, I can't manage those in the Octopus Deploy UI anymore. So if I were to come in here and I were to say change this name from Docker feed TF to just Docker feed, and I just click save, we have a process that runs on a regular schedule, but once every 6 hours or so, that will go through and it will actually rerun Terraform apply and it will make sure that every single one of our spaces is following these standards. I think that was probably the last bit that kind of again took me off by surprise is that once you put a file or a resource into Terraform, it owns that. I don't know about again, I don't know about you, Shawn, but that did that take you by surprise? Because it definitely took me by surprise.
Only a little bit, because that's again, it's similar to how PowerShell DSC works.
Ah,
DSC, you can have slightly two different modes. You can have, say, if it finds that it's been changed, change it back, or simply
mhm.
warn you that it has changed.
Yeah. I mean, you're lucky in that sense that you had a chance to mess around with PowerShell DSC. I never had the chance to kind of do that. So yeah, I was kind of basically just ramming my head into all of these kind of new surprises when I was starting to learn Terraform. So I guess this webinar should be all the things that I learned when I first learned Terraform when trying to do this. Um, but you actually discovered a couple things when you were going through Terraform itself, specifically around some of the documentation. So I kind of want to open the floor to you to let you share some of your experiences.
Yeah, the documentation for the most part is pretty good. There have been some occurrences where I didn't quite find exactly what I was looking for. I was creating some workers in AWS and the what are those images called again? AMIs.
AMIs, yep.
Okay, yeah. So the AMI had a default root disk size that was just a little too small for my needs, and I needed to update it. And it did take me a little bit of time to figure out how to get that to work. And
Hmm.
then in our own provider, I ran into an issue where we were trying to create sensitive variable types and store the value. Uh, there Within the provider type, there's a type called sensitive. There is a flag called is sensitive true, and we thought that was enough to make it sensitive. And there's a if you look above the one, like the variable just above that, it just has value. So we started using just value and thought,
Hmm.
I've already called it sensitive. I said is sensitive is true. That should be all I need. But we found later that that wasn't actually the case. It was never storing the value, and we needed to use the sensitive value property. That just it wasn't obvious at first until we went
Hmm.
back and said, this isn't working. What's going on? and then we found that other property of like, oh, okay.
Yeah, and I think if we looked at the API, we probably would have saw that. Oh, it's called sensitive value because I'm fairly certain I've seen that in the past, but I don't know why I was just so headstrong about just using value. I was like, no, it should work that way. Like all these other properties are set to this. But I think this is kind of highlights some of the inconsistencies you're going to find when you put a wrapper around an API or a CLI. Is that the API and CLI are always going to be one step ahead of the Terraform provider. Um, Sometimes that step is maybe a few hours, or it could be several days, or it can even be several weeks before it finally is updated. But again, I just wanted to kind of point that out. And it's not any real fault of anyone. It's just nature of the beast. I mean, I was like, oh, okay. I mean, once we figured it out, we figured it out, and we kind of have that knowledge from now on out.
Yep.
Yeah. So some of the decisions that we made was based on all of these kind of challenges we were running into. So the first thing that we did is that every single resource, like root resource that's created by Terraform, we wanted to add a suffix of TF. That way we know that's managed by Terraform. Whenever possible, we try to use the description to kind of make it a little bit more apparent. So I think with worker pools, we actually put it a little bit more. This is managed by the Octopus Terraform provider. Please do not make changes in the UI. I kind of backed off from that a little bit, but again, I tried to leverage as much as we could to make sure that people are aware that this is managed by Terraform. You should know that this is managed by Terraform. Um, so we've kind of set up those rules, and then the other couple of things that we made the decision of is we were going to have variable sets, external feeds, infrastructure accounts, as well as worker pools themselves be managed by the Terraform provider. But not everything. When I say worker pools, I kind of want to show you one thing that we changed, which is while worker pools are managed by the Terraform provider, the workers themselves are not managed by the Terraform provider. And Shawn, you're kind of responsible for standing up this whole process of having workers added to these worker pools that we were created by Terraform, right?
Yeah. So as Bob said, the workers themselves aren't managed by the Octopus Terraform provider, but I did use Terraform for each of the cloud providers to create some these workers for these pools, and then iterate through all of the spaces using an API script to go ahead and add those workers
Mm.
to the appropriate pools when they're created.
Okay, yeah, that makes sense. Yeah, so again, this is another use case of where the Terraform provider is not the best solution for this. To me, like Shawn, I'm pretty sure you can probably back me up on this. Is items such as workers or deployment targets, they shouldn't be managed by the Octopus Terraform provider. That's something that should be managed outside of the Terraform provider.
I agree because it's more of a dynamic thing than a
Hmm.
static thing that state can maintain. Because these we spin these workers up and down every week, so
Yeah,
it's not something that it's going to do a really good job of keeping track for us.
yeah, yeah, because we also are leveraging a ton of infrastructure as code to spin up and down not just workers, but all of our deployment targets as well. In this case, it's our AWS lambdas. But yeah, it it's just kind of, now these are Azure web apps. But yeah, it's just kind of a give you an idea of like this is a clear line in the sand to draw. We also made the determination that items such as environments, although every space we want to make sure has test and production, we don't want to have like two environments out of four or two environments out of seven or whatever the case may be managed by Terraform, while the other ones, yeah, you can modify it to your heart's content. That doesn't make a whole lot of sense either. And so what we decided to do is in cases of where we want to have a little bit more flexibility, or we do want to give people to the ability to modify the items within the Octopus Deploy UI, we decided to use API scripts to check and make sure everything was looking good. So, for example, run book retention policies, permissions, the lifecycle policies, as well as the base environments. All of those are managed by API scripts and not by the Terraform provider. But again, we tried to keep those API scripts as minimal as possible. Because if you look at something like even enforcing the base environments, once they get past line 18, we already have more items than the Octopus Terraform provider. Then this is more work to manage. This is more work that we have to maintain because we have to kind of handle all the state behind the scenes. We basically have to check Octopus Deploy. Does this exist? It doesn't. If it doesn't, okay, go ahead and automatically create it. So it again, this is additional code that we have to write. So kind of what I want to do is I want to show you how we're running our Terraform because I think that's just as important as the Terraform provider that we're showing you. And what we've done is we've set up a separate instance called it's our samples admin instance. And this is a private instance. No one has permissions to log into it outside of Octopus Deploy employees. And this is what we're using to manage our main samples instance. So what this does is it uses the Terraform provider API scripts to call out to this instance. We also have a sample sandbox instance that we use kind of to test out new things, try out different processes, everything like that. But again, the same core thing applies, is that this main instance is managing those other items. And I'll show you why we're doing that in just a little bit, because it's going to make a lot more sense. But again, I guess that those are the kind of the big takeaways behind this. And so what we have is we have three main runbooks that kind of handle everything for us. We have enforce system-wide standards, which handles all the permissions across all of the teams. We have enforce space standards, which I'm going to dive into very shortly. And then we have create a new space, because we want to make it easy to create a brand new space for anybody. So let's jump into the enforce space standards. And so how this works is this is running per space. So we have a runbook run per space. And the way that we handle that is we are leveraging a prompted variable. So you can see enforce space standards accepts a prompted variable for runbook's standard space ID. And you can provide it any space ID that you want, assuming that that space ID is on the instance. So how that looks is I call run enforce space standards. I'm going to go ahead and pick an environment, say go ahead and run spaces 1. And then it's just going to pick that up and it's go, okay, I want you to run against that particular space ID. So it's going to take a few seconds probably to spin everything up as it runs all of that for us. You can see the steps that it's going to be running. So we have an API script that's going to make sure that the community step templates are all up to date, or has all the necessary community step templates. So we kind of have a base set of community step templates that we have. And then we have a step that will just run through and just make sure, hey, has anything been modified? Because if we haven't modified a space or we haven't modified a lifecycle, it doesn't make a whole lot of sense to modify any of those types of things. But then finally, we run the Octopus Terraform provider. So let's take a look at this process. So again, we have all the API scripts. But what we're doing down here for step number 6 is we are running the Octopus built-in step to run the apply command. And we are storing everything in S3, as you saw in the previous example. And then all the files are stored inside of Octopus Samples IAC. So if you want to take a gander, you can jump over to Octopus Samples IAC, come into this folder, and you'll be able to see all of our Terraform files. So this is publicly available as well. Let's jump back over here. We are not replacing any variables, and I'll show you what we're doing instead right here is we are using environment variables. So there are really 3 ways that you can send in variable values to Terraform. You can either do it via a variable file, or you can do it via parameters, which, as you can see with all these variables, that would get very unwieldy very, very quick. Or you can use environment variables. And the big reason why I chose to do environment variables instead of doing it inside of, say, a TF vars file is because I didn't want to store this octostash syntax in any of my Terraform files. That way, if I were to ever change the name of a variable, I wouldn't have to then also jump over to my source control and as well as try to keep those in sync. It just made a lot more sense to send those values in. I didn't want to change. I didn't want to send in all those parameters either. You also notice that we are passing in custom init params. So basically, these are all backend values. So key, region, and bucket. That's specific to the S3 backend that we're doing. So every backend has its own configuration values. So we're just sending those in again as parameters because I did not want to store those as variables or octostash inside of here. It would just get very unwieldy, harder to discover, everything along those lines. But yeah, that's in terms of how that Terraform apply step works. That's pretty much it. There's nothing super complex what it does. Now you might be wondering, how do we then call this for every single space? Because as you can imagine, our sample sandbox has a different list of spaces than our main samples instance. In addition, if we added a new space, I didn't want to have to constantly update this process, like add a new value to a variable or update an existing variable. That would get old very, very, very quickly. So this is what the enforce system-wide standards is designed to do. So we do the permission stuff, and then we have this other step that says run enforce space standards runbook. And this is running an API script. So let's jump over to this. And then what this is doing is it's, scroll down to the bottom, we're going to loop through all of the spaces. So that's what the space list does. And then call the Octo run a runbook for that project, enforce space standards. We're giving it the environment that we want to go against. And then we provide that variable name as a space ID. So we're looping through all of the spaces and to say, yep, go ahead and create a runbook run for each space by sending in that prompted variable. So what it ends up looking like is if we come over to our tasks, what we can see is when it says run enforce system-wide standards on test, then it's going to do it for each individual space that we have on that particular instance. So this list will grow as we add new spaces to that instance. But again, we just wanted to keep it as dynamic as possible because, again, I didn't want to have to constantly maintain that. That would get old very, very, very fast. I'm not going to sit here and click on that because it takes a couple minutes to run and it takes about 10 minutes to finish processing everything. No one really wants to sit here and watch that just happen because that could get very old very fast. And then the final runbook we have is this create new space. And I'm going to go ahead and I'm actually going to kick this off. And then we can kind of see this all happen in real time. So I'm just going to run this on our test instance. I'm going to call this demo, assuming I don't hit the mic again. And what this is going to do is going to run an API script to create the space. And then after it's done creating that space, it's kind of like this weird inception. So then it's going to call the system-wide standards, which runs through and adds the necessary permissions. Then it's going to call the the enforce space standards step, which is going to make sure that everything's working good on that one. Of course, I tempted the demo gods, and so now it has to re-upload all the packages and re-download everything. But what we should see in a few minutes is that it has gone ahead and added that space for us. And so I think on average, Shawn, it's taken me about 5 minutes to add a space, which was pretty fast because when I used to create spaces in the past, it would be a couple hour deal in terms of copying everything over. I don't know about yourself if you've found a faster way to do it.
No, I didn't. And I'm very, very grateful for this new process because copying and pasting some of those library sets, even using something like Space Cloner, it still wasn't exactly the easiest thing in the world.
Yeah, I think I think what kind of broke me was when I would say to myself, because we have a library variable set for notifications. So we jump over here, which handles, we have all our messages that we want to use. It has all formatted, nice and pretty. I was like, if I have to copy this one more time, I'm going to lose my mind.
Yeah, I definitely feel you on that one. This new process is, a godsend.
Oh, there we go. So it has finished running it. So if we jump over, we can actually see it kicking off the enforce system-wide standards on test. Now, one thing that we do on this enforce system-wide standards is that also accepts a prompted variable. By default, that value is for space ID is all, which is a keyword that we have in our system that basically says, look at all the spaces. But if you set in a particular space ID, we can actually see it. It will just do all the work just for that one space ID. And so you can see it's just running through for that test. So if we were to jump over here, we can see that we have a new space in our sandbox instance called demo. And I tempted the demo gods by refreshing. There we go. So there's demo. I can switch over to demo. And we can start seeing all the infrastructure get added in there. Sorry. We have environments. We have our workables should be added fairly quickly. So we can jump back. Let's see how things are coming along. Oh, we have all the variable sets already. And we have accounts. Sweet. So just by making a few changes, and as we're talking to you within a few minutes, because we started this back then. So yeah, we are on our way. So that's how our process works over here is it handles all that for us within a few minutes. We are good to go. Now, I did talk about importing existing items into our state. So I'm going to talk about that for a little bit because that's a little bit trickier than what people would think. So I'm going to jump over to this sample script that we have. Simple. I changed this up because I had a really complex example, but I'm like, that is very complex to understand. And I think I spent more time explaining the script than the actual commands that we're trying to do. But basically, the way that the import command works is, let's just scroll down to the bottom because that's the whole point of this, is what you do is you want to run this command called Terraform import, and you want to give it the address of the resource. So the address of the resource is, let's jump back here, is basically this and then a period and then this. So if the resource name is much longer or you have additional items, obviously you copy both of those in. And then it is the unique identifier of the ID value. So in our particular case, it is the Octopus ID. So if we were to jump over to our state file, you can see that the ID is like feeds 1022, for example. So it's the unique identifier for your space for that particular external feed. But to get to that point, to get to the point of just running this command, you also have to run the Terraform init. And so you have to populate like the backend config, just like how I have previously. You also have to provide all of the variables. So this is just a small sampling of all the variables that we have, as well as the variables for the backend authentication. So it is a bit of work to get to that point, but it is completely possible to import values into your Terraform state if you already have it. Just note that it can get rather tricky at times. In our particular case, I wanted to have a script that could run across all of our spaces and not have to go through and run that for 50 times or however many spaces we have. I think it's 34 at the time. And then checking each time. I could just imagine all kinds of copy paste errors and just random errors. So I have this very complex script that I wrote that's leveraging the Octopus Deploy API, does a whole bunch of checks, does all kinds of different things. So you can get as complex or as simple as you want it to be. But yeah, I just wanted to point that out, that it is completely possible to import items into Terraform state. So that's something that you'll need to do if you have existing items that you're going to add into Terraform that you want to have be managed by Terraform from now on. So that's the overall process that we have. Now there was still quite a bit of work to do because Shawn, even though we created all these resources like the notification TF, for example, or the Azure TF or whatever the case may be, you still had to go through each of the processes and update to use these new library variable sets. And it wasn't just like, okay, I've created all these resources in Terraform, good luck. And everything works just perfect.
That's absolutely right. And as part of this effort, we were also consolidating on what we were doing because a lot of these spaces would create their own resources, such as subnets, virtual networks. And it led to be a bit messy. There was just a whole bunch of them there. So as part of this effort was to also consolidate onto using common virtual networks and subnets and stuff like that. So not only did we have to clean up the usage, we actually had to, and this is where I was talking about those ARM templates. I had to go through those ARM templates and remove the portions of where it actually created those VNets and point it to the new one, which was a little bit of a learning experience, but useful in of itself.
But the nice thing is we already have all those variables and all those values. So hopefully that was a little bit easier than the earlier effort when you're going through and kind of changing around some of those standards.
Yeah, it definitely was easier. Having this established and just pointing into the right resources made it a lot nicer. There's still some work that has to occur. As you can still see, there's Azure TF and Azure. Um,
Yeah.
we're doing an iterative approach on cleaning this up. So most of it has been moved, but we have a couple of things we still need to clean up in there as well.
Yeah. And so and I think that's perfectly fine. Yeah. This is kind of just, again, to establish those standards from the get go. So, but that's basically everything we've had for our demonstration. So what we're going to do is jump back over to our presentation and let's talk about some Q&A. Okay, it looks like we have some questions that are coming in. Um, Shawn, I'd be kind of curious to get your thoughts on this. Can I use the Octopus Terraform provider to manage my deployment process? What's your opinion after you've kind of had some experience using the Terraform provider?
The short answer is yes, you can. The biggest reason I wouldn't is because Terraform now owns that process, as you've already stated. It
Yeah,
you, the the advantage of using something like config as code is that you can make changes both in your code or the UI. Whereas if you're using the Terraform provider, that now has to be done through Terraform. You can't really change it in the UI, and if you do, it's just going to set it back.
yeah, I absolutely agree. Like if you're a team that you want to manage your deployment process, and every team kind of has a unique deployment process per application, I 100% agree. I think a tool such as Config as Code is much more suited to that. But I do think the Terraform provider can have some flexibility if you're looking at maybe having a standard like this is how we deploy to Kubernetes, and this is our one process, and every single there's no give or take in terms of that deployment process. It has to be that, and you want to have it be the same thing across all your projects. Then maybe I could see that, but that's a pretty big undertaking because you have to go through and you're going to have to import some stuff into Terraform State and convert those steps over to HCL, which actually is funny. I mentioned that because I just saw another question pop up. Is there something out there that can take an existing resource and convert it to HCL? So I assume that's an existing Octopus Deploy resource. The short answer to that is no. You would have to write something yourself or hand create it yourself. So that there is that hurdle that you're going to have to overcome. Another question, can you use the Terraform provider to configure HA? Shawn, do you know off the top of your head? My guess is I'm going to go with no, probably, because that's more system level settings, not instance settings, because you're not managing that via the API.
Yeah, in messing with the Terraform provider, I didn't see anything that was node specific. This was
Yeah,
just all some of the underpinnings of Octopus Deploy. So I'm going to agree with you. I don't think you can do that with the Terraform provider.
yeah. Changing topics a little bit, would you recommend splitting up the Terraform files according to component or lumping them all into one file? I I think it's a matter of preference. Eventually, you can start off with one main file uh, and have everything defined here, including your variables and all your resources. But as our Terraform files grew, it just became unwieldy. Like I was scrolling for days anytime I wanted to add something new. So my opinion is have it be a separate group of files. Shawn, do you have any thoughts on that one?
My thought is exactly like yours. I mean, like you said, you can lump it all into one. That's what Terraform does in the end when it
Hmm.
combines everything anyway. but just for sheer manageability and separation of components, so easier to find something, is if we just had variables, just library sets versus AWS, Azure, and GCP,
Oh
I'd
yeah.
have to keep going through those. And it's a good separation just to keep them together, because otherwise you're going to have to sit there and search for them. And humans being humans, you might miss something. So
Oh
having
yeah.
them separated out is definitely better.
Yeah, I can only imagine. I mean, I'm already scrolling for days just on this is just a single library variable set. So I can't imagine what it would look like with all of those files combined. Yeah, I would probably I can even take it a step further and maybe separate this out: Azure Library Variable Set, UK, and then US, and everything like that. So there's definitely flexibility, and it is very easy to create a new file and then check it into source control. You don't have to do anything super fancy outside of cut and paste to different files. So hopefully that works out pretty well. Um, I guess, and it looks like we got one final question. Using the Terraform provider to manage sensitive variables, it looks like they could be available as plain text in the state file. Do you have another recommended approach? So yeah, that is a very interesting question. So any value, any property that you put in here it will be stored as plain text in your state file. That's how Terraform knows that something has changed. Uh, that is a bit of a security concern. So always first store your state file in a secure place. I don't recommend storing it on a file share unless that file share is locked down completely. We opted to use locked down S3 bucket with only very limited permissions in terms of who could access that. I know that you can use Azure. I know you can use Azure's one of their file. I think it's either file storage or their blob storage. I know HashiCorp has an option, but there might be some other options as well. Shawn, what are your thoughts on that?
The only thought that comes to mind is not doing it at all and
No, fair enough.
integrating with a secret store, whether that's Vaults, HashiCorp, Azure Key Vault, or something like that, some third party place to keep those things separate so they're not available as clear text.
Yeah, I mean that definitely is an approach, and I know that was on our list of things to do in one of our iterations, and so we'll probably revisit that at some point in the future. But yeah, I think that is a really good point on something like that. Awesome. Well, that's it for the Q&A. We're just going to go ahead and wrap this up. Uh, if you want to talk to Shawn or myself about the Terraform provider or anything along these lines, please reach out to advice@octopus.com. When we do say consultancy, what we're referring to is more like we're just going to give you some guidance, some pointers, what to do, what not to do, everything along those lines in terms of what we offer for free. If you're interested in becoming an Octopus Deploy customer, is just if this is your first webinar and you're not familiar at all with Octopus Deploy, please reach out to our customer success team by going out to customer success at octopus.com. They'd love to talk to you. And if you want to see more webinars like this or getting started videos or any number of different types of videos, we have a YouTube channel. Go ahead and subscribe to it. We'd love to be able to give you more of this great content. And thank you very much for attending. Shawn, I don't know about yourself, but I had a blast talking about this. I love this topic.
Yeah, state is something I'm very passionate about. I really like it.
Yeah. And if you're interested in our next webinar, it's going to be happening on April 6th, 2022, where Pete and Sarah are going to be talking about getting started with Amazon ECS and Octopus Deploy. I think that's going to be another really, really, really fun webinar to talk through how to use that. So again, thank you very much, everyone, for joining us, and have a great rest of your day.